Welcome to Tight Tutors. Centrifugal tension. As the belt runs over the pulley, some centrifugal force is caused, whose effect is to increase the tension at the slack side and also the tension at the tight side. Now, considering this diagram, we have the portion PQ, which subtends an angle theta at the center of the pulley, d theta. Then this is the radius. Now, this is the centrifugal force. Now, this centrifugal force, it causes an increase of tension at the slack side and also an increase of tension at the tight side. At this slack side, we have the centrifugal tension, and at the tight side, we also have the centrifugal tension. Now, m is the mass of the belt per unit length in kilograms. V is the linear velocity of the belt in meters per second, and r is the radius of the pulley over which the belt runs, and Tc is the centrifugal tension caused by the centrifugal force. Now, considering a small portion PQ, now the length of PQ, now the length of the portion PQ is going to be r times d theta. Now, then the mass of that portion, now the mass of PQ is now going to be m times r d theta. Now that is now the mass of that portion PQ. Now we know that the centrifugal tension is equals to mass times v squared over r. That is now the centrifugal force. Now we have mass as mRd theta. Now F centrifugal force is now going to be m r d rm d theta v squared over r. Now that is going to be our centrifugal force, which is equal as writing when we cancel this with r, is going to be m d theta v squared. Now that is our centrifugal force. Now the centrifugal force acting, this centrifugal force acting tangentially at P and Q, it causes the belt to be in equilibrium, meaning the centrifugal force at PQ is equals to the tension at the slack side plus the tension at the tight side. Now, resolving all the forces horizontally and equating the same, we are now going to have sine, dc sine d theta divided by 2 plus dc sine d theta divided by 2 is equals to the centrifugal force m d theta v squared. Now, since sine d theta over 2 is very small, we are going to replace it with d theta over 2. Since sine d theta over 2 is very small, we are now going to replace it with d theta divided by 2. Now, dc d theta divided by 2 plus dc d theta divided by 2 is equals to m d theta v squared. Now, this one is the same as writing 2 dc d theta divided by 2 is equals to m d theta v 2 v squared. Now, to find the centrifugal tension, or to find the centrifugal tension, we are now going to cancel this. This 2 goes by that 2. Now now this 2 goes by this 2. Now Tc d theta is equals to m d theta v squared. This one goes by this one. This one goes by that one. Now Tc equals now to m v squared. Now this is not the centrifugal tension in a belt drive, which increases the tension at the tight side and also the tension on the slack side. This is not the centrifugal tension. Thank you for watching this video.